Let us go for the next term, that is heat capacity and specific heat capacity. For that, consider a body of mass 3 kg. I am taking here a ball of mass 3 kg. Okay. And its temperature is 20 degrees Celsius. Its temperature is 20 degrees Celsius. Okay. Another ball, or we can consider cylinder. Okay, here another cylinder. One cylinder is there. That is of 2 kg. Let me say 2 kg. And its temperature is 20 degrees Celsius. Okay. Now, I am planning to supply heat energy here. Heat is being supplied. And here also I am supplying heat energy at the same rate. Here imagine I have supplied 3900 joule of heat energy. 3900 joule of heat energy is supplied to this ball. And 3900 joule of heat energy is supplied to this cylinder also. Okay. Now let me say its temperature increases to 30 degrees Celsius. Here its temperature it will be 25 degrees Celsius. Well, so now some simple questions. Let us take this one. What is the heat energy required? My question is very simple and direct. 3900. Okay, 3900 joule. You understood that because this rise in temperature here, this rise in temperature is 30 minus 20, that is 10 degrees Celsius. To increase the temperature by 10 degrees Celsius, I have to supply 3900 joule of heat energy. Okay. Is here, this one I can write in Kelvin scale also. 20 degrees Celsius is equal to how many Kelvin? 20 plus 273, that is equal to 293 Kelvin. And this 30 degrees Celsius, if I express that in Kelvin, it will be 303 Kelvin. What is the difference there? 10 Kelvin. So that is what we have already taught. A difference of 10 degrees Celsius is same as the difference of 10 Kelvin. So here, excuse me, heat required to increase the temperature of the ball by 10 degrees Celsius. Instead of that, I can write heat required to increase the temperature of ball by 10 Kelvin. Then also same thing, isn't it? But now I am writing in terms of degrees Celsius. Okay, let us continue with the degrees Celsius. Next question is heat required to increase the temperature of the ball by 1 degree Celsius. How much heat is required? Can you tell me?
390 joule.
390 got like this, 3900 joule divided by 10. You got the answer 390 joule. Okay. This 390 joule is the heat energy required to raise the temperature of this ball by 1 degree Celsius. Now I am using a special term. The term is heat capacity. Heat capacity of the ball is, I will say, 390 joule per degree Celsius. So heat capacity of this ball is 390 joule per degree Celsius. If I say like that, what will you understand?
The ball needs 390 joule for moving the temperature of the ball to change from 1 degree Celsius.
Yes. To increase the temperature of this ball by 1 degree Celsius, it needs 390 joule of heat energy. Okay. The same thing I can say like this also. Heat capacity of the ball is 390 Joule per Kelvin. This is also correct. Same thing only. What does this mean? The
It
ball
requires 390 to change the temperature ball from 1 to 1 Kelvin.
390 joule of heat energy is required to increase the temperature of the ball by 1 Kelvin. Both are same only. Okay, so from this it is very clear. What is the SI unit of heat capacity?
Joule per Kelvin.
Joule per Kelvin. If somebody says, one child says joule per degree Celsius, is it correct? That is also correct. The reason is that the change in temperature, what I told you, difference in Celsius scale, that is same as the difference in Kelvin scale. So if I ask you to find the heat capacity of this cylinder, can you find? Heat capacity of the cylinder. Let me use a symbol for heat capacity. C dash. C dash is the symbol I am using to represent heat capacity. Okay. What will be that? That's equal to 3900 joule divided by 25 minus 20 degrees Celsius is equal to 780 joule per degree Celsius. That's it. So it is very easy, you understood that it needs 780 joule of heat energy to increase its temperature by 1 degree Celsius. This one needs only 390 joule of heat energy to increase its temperature by 1 degree Celsius. It has more heat capacity, so it needs more heat energy to increase its temperature. Heat capacity, see what is that? We got 390 joule per Kelvin. Okay. This heat capacity, I am going to divide this heat capacity by mass. That means the heat capacity per unit mass. Heat capacity per unit mass. Here what is the heat capacity per unit mass? 390 joule per Kelvin or joule per degree Celsius. Both are same, please understand. I go for joule per degree Celsius here. Joule per degree Celsius divided by, what is its mass? I told its mass is 3 kg. On dividing I will get 130 joule. This kilogram is there in the denominator, so I can take it to the numerator, then it becomes kilogram to the power minus 1. This already per degree Celsius is there, that is again right like this. Okay. Now I am getting another quantity. This quantity is known by the name, what is that? Specific heat capacity. Specific heat capacity. Specific capacity is represented by the letter small c. Okay. The specific capacity of what? Specific capacity of what? This 130 joule per kilogram per degree Celsius is the specific capacity of what?
Ball.
For specific capacity of the ball. We will not say that way. It is not the specific capacity of the ball. This is the specific capacity of the material by which this ball is made. Material of the ball. That specific capacity is a characteristic property of the substance. Every substance will have a particular specific capacity. This specific capacity is the characteristic property. When I say the specific capacity is the characteristic property, you must understand from this you will be able to identify the substance. Just like density. The density is 13.6 gram per cubic centimeter. If I say like this, you will identify the substance. What is that substance?
Mercury.
Mercury you will say. Okay, very good. In the same way, if I say specific capacity is 130 joule per kilogram per degree Celsius, you will be able to identify the substance I am telling. With the help of your textbook, can you guess what is the substance? What it might be? You can take the help of your textbook. They have given the specific capacities of different lead. Okay, very good. That's what I wanted to say. Specific opacity is the characteristic property of a substance. So you identified the substance as a lead. Okay, good. The specific opacity of a lead is 130 joule per kilogram per degree Celsius, means 1 kilogram of lead. 1 kilogram of lead requires 130 joule of heat to increase its temperature by 1 degree Celsius. Now my question, can you identify the substance? What should I do? What should I do? I will find the specific opacity of the substance. Okay. So specific opacity of the material of cylinder. Specific opacity is C is equal to C dash divided by mass. C means specific capacity, C dash means heat capacity, M stands for mass. So this heat capacity already I have found, 780 joule per degree Celsius divided by its mass. Mass is 2 kilogram. Okay. So on dividing I will get what is that number? 390 joule per kilogram per degree Celsius. So I am writing like this. You don't write like this. This is wrong way of writing. Joule per kilogram per Kelvin or per degree Celsius. Don't write like this. This is wrong. Joule per kilogram. This is correct. This is wrong. Or you have to go for this way. Okay. Now 390 joule per kilogram per degree Celsius. Can you identify the substance? From the data given in your book, the most matching one. Zinc. So that is what I have to say. What? Specific capacity is the characteristic property of a substance. In your textbook, you will see 391 joule per kilogram per degree Celsius. No issue. Here I just wanted to say that every substance has a particular specific capacity. Okay. The first one I told you like this, heat capacity. To find heat capacity, what formula did I use? I used delta Q by delta T. Okay. Specific capacity. Specific capacity I wrote C dash divided by. That means this heat capacity C dash is equal to rearranging this one, the second formula. I will get C dash is equal to M into C. This specific capacity is a constant. That's a characteristic property of a substance. Okay. So C dash, heat capacity depends on what? Of course it depends on the material, no doubt. For a given material, heat capacity depends on what? For a given material, heat capacity depends on a mass. It depends on mass. Heat capacity depends on mass. If mass changes, heat capacity changes. Mass increases, heat capacity increases. That means 3 kilogram lead and 5 kilogram lead. 5 kilogram lead will have more heat capacity. There is no doubt. More heat energy is required to increase the temperature of a 5 kilogram if you compare it with the 3 kilogram lead. Okay. Well, now just compare this first equation and this one. I can equate like this. Right hand side I can equate delta Q by delta T is equal to MC. Am I correct? Left hand side same. I can equate it like this, right? I am interested in this delta Q, heat taken by the body, or heat supplied, or heat gained, heat required. Whatever the word you are using, doesn't matter. Okay. I'm talking so far. I told about the increase in temperature of a body. So here it is heat required. Sometimes heat will be released also. Okay, then I must say about fall in temperature. A generalizing case means heat taken by the body or released by the body. Okay, heat required delta Q is equal to, when I rearrange, I will. This formula is important. This is the formula which we use to find the heat energy released by a body or gained by a body during temperature changes. Delta Q is equal to MC delta T. Capital T or small t, not very big issue. Small t generally we will use when we express the temperature in degrees Celsius. Capital V we will use when we express the temperature on Kelvin scale. But here difference in temperature on Kelvin scale and that in Celsius scale is the same, no? So this formula. Okay. Remember this formula. One simple numerical problem. I'm sorry, my sound is not okay. An iron ball of mass 1.1 kilogram requires 5000 joule of heat energy to raise its temperature by 10 degrees Celsius. Temperature by 10 degrees Celsius. Calculate the heat capacity of iron ball to calculate specific capacity of iron. Understand the difference in the question. Okay, first one is calculate the heat capacity of iron ball. Heat capacity is for a body, but specific capacity is for the material. Okay, well, easy. How will you find? First you write the given data. What is given? Heat supplied is given. Delta Q is equal to 5000 joule. First part of the question. We need to find the heat capacity V in delta T. Delta T is equal to what is that? Well, they have given it 10 degrees Celsius directly. 10 degrees Celsius. Or it is equal to 10 Kelvin. Let us go with this only. So heat capacity is equal to what? Delta Q by delta T. That is 5000 joule divided by 10 degrees Celsius. So answer is 500 joule per degree Celsius. Okay, second part of the question. What we need?
Sir.
Yes.
Sir, heat capacity, that C can be capital or small, no problem.
Heat capacity?
So that C can be capital or
C,
small.
no, that is not a very big issue. Generally, to identify, we are using C dash. Capital C and small c, we are writing on this, may not be able to identify. Small c is used for specific capacity, okay. And capital C, if we use for heat capacity, identification problem is there. So we are using this dash. So even if you write C dash for heat capacity, that is not a big issue. But symbol is not as standard as you think. In some other books, you may come across some other symbols. Well, and then what? Next, specific capacity. Specific capacity C is equal to what? C dash divided by mass. M. So what will be the answer? 500 joule per degree Celsius divided by 1.1 kilogram. Find it and tell me.
454.54 joule per kilogram per degree Celsius.
454.5. Is it so?
Yes, sir.
Okay, I did not calculate.
Yes, sir.
Okay, if it is like this, joule per kilogram per Kelvin. Or you can write joule per kilogram Kelvin. Okay. That's all. So here one substance is there, another substance is here. Here Ix joule of heat energy is applied. Here X joule of heat energy is applied. Its temperature increases by 3 degrees Celsius. Its temperature increases by 1 degree Celsius, which is having more heat capacity.
Mass is same.
Mass may be same, may not be same, I don't know.
Sir, what you asked?
Which is having more heat capacity. Heat capacity of A, heat capacity of B, which is greater. Hello?
Sir, question you what that is not understood. Once again, if you can ask.
I supplied X joule of heat energy, X joule. Here also I supplied heat energy. I supplied X joule. Same thing. In both the cases I supplied same amount of heat energy. Here I noticed that its temperature increases by 3 degrees Celsius. Here I noticed that the temperature increases by 1 degree Celsius. Delta T is 1 degree Celsius, delta T is 3 degrees Celsius. My question is simple. Which is having more heat capacity? This one. Heat capacity of which one is greater than the other? Heat capacity of B is greater than A. Yes. I am modifying my question. Same statement I am giving. My question I am changing. What is the ratio of heat capacity? Ratio of heat capacity of A and B.
Two is to three.
2 is to 3.
So, sir, 1 is to 3.
To 3.
1 is to 3. 1 is to 3 now. Mass of this one is 5 kilogram and mass of this one is let it be 6 kilogram and mass of this one is let me say 2 kilogram. Okay. What is the ratio of their specific heat capacities? What is the ratio of specific heat capacities?
1 is to 1.
You got it. Specific